Okay, so in this example, I'd like to look at a supply and demand problem. And this example is actually broken up into two examples in your text, which can be found in section 1.2, if you'd like to go look for those there. So we have in particular that the demand for private schools in the state of Michigan is given by the equation Q equals 77.8 times P to the negative 0.11. This is given in thousands of students, where P is the net tuition in dollars. We also know that the Michigan private school industry is able to accommodate Q equals 30.4 plus 0.006 times P, 1,000 students, where P is the tuition amount in dollars as well. So the first thing that we're asked to do is find the equilibrium tuition price. So find the exact tuition that will neither give a surplus nor a shortage of openings. And we're going to do this graphically. So we want to graph the supply and demand curves together. And then, of course, we're going to look for the intersection point of these curves. And that will give us the equilibrium tuition price. So what I've done is I've opened up a Desmos window. Let's just minimize that so we can write these equations in here. We're going to put just both of them in there as they're written. So the first is Q equals 77.8 times P to the negative 0.11. And the second one is Q equals 30.4 plus 0.006 times P. And let's maximize this browser. And you'll notice that the equations are over here on the left-hand side. There doesn't seem to be an error. However, I don't see a graph. So what we're going to do is start zooming out and see if we can locate it. So we see something here. This purplish line appears to be the second equation because of the coloring system. If I zoom out a bit more, I start to see the green one, which is the first equation. Now we're looking for the intersection point of these graphs, and it doesn't appear to be on the left-hand side because it looks like the green equation, the green graph, will shoot up very quickly here. So let's just scroll over to the right-hand side until we locate the intersection of these graphs. Oh, it looks like we found it. You can sort of tell because on the left-hand side, the purple equation, the purple graph is on the bottom, and then on the right-hand side, the purple is on the top. But to find the exact intersection, it might be useful to adjust our window a bit. It looks like we need to zoom in a whole lot in the Y direction. So to zoom in specifically in one direction, not the other, we're going to click on the wrench icon up here. So let's zoom in between, what does this look like? So down here is negative 50, and this is positive 50. So if we zoom in maybe between 25 and 50 in the Y direction, so 25 to 50. Perfect. So now we see our intersection point very nicely. And remember that equilibrium price is obtained by looking at the intersection of the demand and the supply curves, right? So there's the demand one, that's the green, and then supply is purple. And remember that the demand function usually is a decreasing one. So as price increases, so in other words, as P goes towards the right, the demand equation, the demand curve is going to decrease. And we can verify that by looking at the green equation, the green graph, and seeing that it is a decreasing function and the purple one is increasing. Now we're looking for the intersection of these two, and Desmos is really nice. If you click somewhere where it looks like the intersection is, it takes you right to it. So it says that the intersection occurs at 998.98, 30.394. So what I want to do is write this down. So the intersection point is, what did I say that was? 998.98, 998.98, comma, 36.394. Oops. 36.394. And what are each of these coordinates? Remember the first coordinate corresponds to whatever's on the horizontal axis, right? And that's going to be P, and the vertical axis will be Q. And how do I know that? Well, these equations are given in terms of p. So p in this case is the independent variable, and the independent variable always goes on the horizontal axis. And then, of course, q would be the dependent variable. This thing always goes on the vertical axis. Remember that supply and demand both depend on p, so they are dependent, and they're dependent on whatever is the independent variable, which is q in this case. So this gives us that p is equal to 998.98, and that q at that intersection is equal to 36.394. So to see what these things mean in particular, to look at their units, let's go back to our example. So we know that in each case, Q has a unit of thousands of students, right? And P has a unit of dollars. So P has a unit of dollars. So I can say that's equal to $998.98, $998.98, so almost $1,000, just shy of that. And 36.394, remember Q has units of thousands of students, so 36,000 students. So this is, I need to move my decimal point over, 36,394 students accommodated at that equilibrium price. Notice we weren't asked to find that value of Q, we weren't asked to interpret it, but it's nice to know that, right? So we have an equilibrium price that's about $1,000. That's the optimal price that should be charged in order to fill all the seats and not have vacancies. And that's sort of as much as the demand will pay, if that makes sense. And that will accommodate 36,394 students. So in Part B, we want to know that if the tuition is $1,200, which notice is a bit more than our equilibrium price, right? If P is $1,200, will there be a shortage or a surplus? Well, it seems that there should be a surplus of openings. If we go back to our graph, remember that if we're over here to the right, so for a larger value of P, the purple graph is larger and the green graph is smaller. So demand has gone down and supply has gone up. So it seems that there should be a surplus. So at P equals 1,200, there should be a surplus. We're doing that intuitively. But to figure out exactly what that surplus would be, Desmos will actually do that for us. So to get Desmos to calculate that, instead of writing just the equation Q equals blah, 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 I want to specify that Q is a function of P. So Q of P is equal to this stuff. And then down here, Q of P. Now, we have a bit of a problem because this looks like they're the same function. So I'm going to specify that this is the demand function and that is the supply function. And the reason for that you'll see in a second. I want to figure out exactly what the demand is when P is 1,200 and exactly what the supply is when P is 1,200. So the demand of 1,200, and Desmos calculates it for us, it's 35.667, and the supply at $1,200 is 37.6. So let's go ahead and put this into our notepad here. So demand when P equals 1,200 is 35.667. And remember, this is in thousands of students, right? So this many students, or parents of students, I suppose, will pay $1,200 to put their kids in private school. And the supply when P is 1,200 is what? 37.6. And remember, this is in thousand again. So we're going to move our decimal place over 3 to the right, which gives us 37,600 students, which means that the private school industry has opened up too many spots, right? All of them won't be filled because only 35,667 students will fill spots at that price. So what's the difference there? 37,000 minus 35,667 is 1,333. Okay, so, and actually we can put that up here. There should be a surplus. The surplus is 1,333 students. That's how many extra seats there will be at that price. And that answers all of the questions for this example.